Graphing exponential functions. So first, an exponential function, that's just like b to the x power. So that could be any number, like 2 to the x, 3 to the x, 1/4 to the x. It could be any number, and it's just growing exponentially. You have done these before. You did these in secondary 1. So hopefully this is kind of review. So if b is greater than 1, then the function is an exponential growth, and it is increasing the whole time. So that means it's going to look something like this. Now, if b is less than 1, if b, what's happening? If b is less than 1, that should say less than 1. Less than 1. It's an exponential decay, and it's decreasing. So increasing looks something like that. Decreasing just looks like that. Okay. Now, let's look at this. So, remember, that should say if b is less than 1, then it's a decay. That's my bad, sorry. Now, classify as an exponential growth or decay, and then identify the features and graph it. So, 2 is greater than 1, so that's an exponential growth. To graph this, let's just make a table. So, we're going to go from -2 to 2. Then we can just plug these numbers in. So first, anything to the 0 power is 1. So 2 to the 0 power is 1. 2 to the first power is 2. And 2 squared is 4. Now 2 to the -1 power is 1/2. And these will always be reciprocals of each other. Okay, so if this is 1/2, 2 to the -2nd power, that's going to be 1/4 reciprocals. Okay. Now we can just graph this. So we have 0, 1, 1, 2, 2, 4. You could also do 3, 3, 8. And then the left side, it's hard to tell with this because I drew my point so big, but that's what it's going to look like. And it never crosses over that line. So our domain here is -infinity to infinity. Range is 0 to infinity. As x goes to -infinity, f of x goes to 0. As x goes to infinity, f of x goes to infinity. There's a y-intercept at 0, 1, and an asymptote at y equals 0. Okay, let's do this one. So here, you can do b if you want. So 2/3 is less than 1, so this is a decay. So we can do a graph or a table again. Anything to the 0 power is 1. 2/3 to the first power is 2/3. 2/3 squared, just square the top, square the bottom, so it's 4/9. Which then you can do the reciprocal for -1, so that's 3/2 and 9/4. Okay, so we have 0, 1, 1 2/3, 2 4/9, and then -1 3/2, and -2 9/4. It's going to look something like that. From those 5 points, you can get a gist of what's going on. So this is -infinity to infinity, 0 to infinity, and there's not a bracket at 0 because that's an asymptote. As x goes to -infinity, f of x goes to infinity, and as x goes to infinity, f of x goes to 0. Y-intercept at 0, 1. And there's an asymptote at y equals 0. Okay. Now let's get into the transformations. So here's our parent function. -a times b to the x minus h plus k. H is the horizontal shift, so that's left or right. K is the vertical shift, so that's up or down. If a is negative, it's a reflection across the x-axis. If a is greater than 1, it's a stretch, and if it's less than 1, it's a compress. So let's just look at these and identify the transformations. So the parent function here is 3 to the x. Now that plus 5 moves it up 5. Parent function here is 1/4 to the x. The 2 is a vertical stretch by 2, and that -1 moves it right 1. You can do f for g, so that's the parent function, 5 to the x. It's 1/2, so that's a vertical compressed by a half. Right 4 and down 2. And let's actually graph this. So here our parent function is 2 to the x, and that plus 5 moves it left 5. So I'm going to go left 5 and just draw a line there. And this is where we're going to graph it from. This is like our, I'll call it our new axis. It's not, we still are working off like 0, 0 is still right here. But to graph it, it's going to be easier if we graph it from this line. Okay? And we're still going to make our table, but we're just going to use 2 to the x for this table. We're not going to do the x minus or x plus 5. We're just using 2 to the x. So then that's going to be 1, 2, and 4. So that's 1/2 and 1/4. Now we're going to graph these from our new axis. And when I say new axis, I mean like in quotation parts new, or quotation marks. Okay, it's not really new, it's just a kind of a trick to graph this, okay? So negative 2, 1, 4, so from, oh, we could do 3, 8 also. So we have 0, 1, 1, 2, 2, 4, 3, 8. And then those two are just super close. There is our graph. Okay. And see, the reason we're going to use this new axis is because that shifts it for us. So that shifted left and that shifted it, oh, it didn't go up or down at all. So it shifted it left. Then we don't have to do anything and you can graph it the same exact way. Okay. Our domain is negative infinity to infinity. Range is 0 to infinity. As x goes to negative infinity, f of x goes to 0. As x goes to infinity, f of x goes to infinity. Our y-intercept, if you can't see it, like we can't see it on this, just plug 0 in. So 2 to the 0 plus 5 is 2 to the 5th, which is 32. So we have a y-intercept at 0, 32, and an asymptote at y equals 0. Okay? Let's do another one. So this one, our parent function is 3 to the x. We're vertically compressing by a half, and I'll show you how to do that, and we're moving up 1. So the up and down, left and right, that's where we're going to draw our new axis. So we moved up 1, so that's going to be our new axis. We're still going to make a table. For this table, we're going to use 3 to the x. So we're going to use our parent function. So that's going to be to the 0 power is 1, 3 and 9, 1/3, 1/9. But we are vertically compressing by a half. So to vertical compress something, vertical axis, that's your axis that goes up and down, which is your y values. So to vertically compress your y values, we're going to multiply the y values by 1/2. So we're scaling the y values by 1/2. So that's going to become 1/18, 1/6, 1/2, 3/2, and 9/2. Okay, so again, we started there, multiply them all by a half, and that's where you get those numbers from. Then we can graph this. So 0, 1/2, 1, 3/2, 2, 4, 2, 9/2, or 4.5. And I'm not going to draw those left points. And that's where that's at. So our domain, negative infinity to infinity. Range is 1 to infinity. As x goes to negative infinity, f goes to 1, f of x. As x goes to infinity, f of x goes to infinity. Y-intercept at 0, 1.5. And asymptote at y equals 0. Okay, let's do one more. So here we have our parent function is 4 to the x. It reflects the x-axis because of the negative sign. The 2 is a vertical compression by 2. That should have said stretch. Yeah, that should have said stretch. Sorry. Vertical stretch by 2. And then that minus 2 moves it right 2. That's okay. Now, that right 2, we're going to draw it right there. We're still going to do our table, and we're going to work off the parent function 4 to the x. So 0 power is 1, 4 and 16, 1/4, 1/16. But to reflect the x-axis, so normally all of our points are going to be up here, right? But we're reflecting the x-axis, so that's going to flip it down, so it's actually going to be down here. So that means that our y values went from being positive to now being negative. So we just need to switch the signs of all of our y values. So that's going to be negative 1/16, negative 1/4, negative 1, negative 4, negative 16. We're also vertically stretching it by 2. So that means we're scaling the y values by 2. So we're going to have to multiply those all by 2. So instead of being 1/16, it's 1/8. Instead of 1/4, it's 1/2. Instead of negative 1, it's negative 2, negative 8, and negative 32. Okay, so negative 2, negative 1/8. I'm not going to graph those. Negative 0, negative 2, 1, negative 8. That one's off the graph. Negative 1, negative 1/2 is right there. So that's what that one looks like. Okay, it flipped over the y-axis. Domain is negative infinity to infinity. Range is negative infinity to 0. As x goes to negative infinity, f of x goes to 0. As x goes to infinity, f of x goes to negative infinity. Y-intercept is 0, negative 1/8. And the asymptote is y equals 0. Okay, thanks for watching. Please remember to take the quiz.